Hey guys, this is Abhishek and welcome to my channel One Day Batting. In this video, we will discuss about implementation of stack and let's start the video.
Okay, we discussed what is stack in the previous video. Now we are going to discuss implementation of stack. Okay, now okay, we already know that stack size is fixed. So the size is fixed, right? We are implementing this in using C language. Okay, let's say int size equals 5. Now we should declare a stack with size. We can do that by declaring just an array of size, but we cannot declare a stack variable using size. This is the variable, right? We cannot do it in this way. Either we can use any constant or a macro. So here we are using macro. We can declare a macro by using as defined statement. Okay, we declare the macro by using this as defined statement. Now for my macro, there is a condition that we should write all the letters in capital and the value. Here we have 5. Remember, there is no semicolon, so here no need of this global variable int size. Now here, while declaring the stack variable, again we should use capital letters. So we declared a stack of size 5. 1 2 3 4 5. So size of the stack is fixed and the index of this stack starts from 0. Now in the previous video I said that there is a variable called top for a stack, and again stack, okay, let the size of this address of this stack be 2000, then it is 2002, it is 2004, it is 2006, and this is 2008. Integer occupies 2 bytes of memory in C. So stack variable contains the initial address, that is 2000. Now top is a global variable which contains initially -1. If stack is empty, then top is -1. As while pushing some data elements into the stack, we increment the top and then we push it. So if we have 10 here, top will point here and this -1 will be 0. And if we push 20, top points to first location and this top will be 1. Index of the topmost element is the top. Now okay, we declared a stack variable and top. Now coming to push operation. Push operation just takes an element and returns nothing. So returns nothing, void push, but takes an element, right? So integer, an element. Now push, first of all we should check whether the stack is full or not. If is full is a method. I will explain it later. If this stack is full, checks whether the stack is full or not. Okay, if the stack is full, then print stack overflow. Else we should increment the top and then we should insert the element into the stack. So to increment the top, we use top plus plus, and then we should insert that element, right, this given element, this element into the stack. So stack of top equals element. Printf element, percentage d pushed into stack. That is element. Okay, let's check whether this will work or not. First of all, let the data elements be 10, 20, 30, 40 and 50. Okay, first of all, we will call this push function using 10, parameter, by passing the parameter as 10. Okay, it checks whether it is full or not. Initially stack is empty, so it returns false. Top plus plus, initially top is -1, right? Okay, top is -1. Here top plus plus, it will increment to 0, -1 incremented, so it top is now 0. Stack of top equals element. Stack of what is top? Top is 0, so stack of 0 is the element. So we inserted the element 10. Now we will print the statement that 10 pushed into the stack. Now 20, push of 20, right? It checks whether it is full or not. We can see it is not full, so false statement. It comes into the else part. Again top plus plus, top will be incremented to 1. Now top points to first position, index 1. Now stack of top equals element. Stack of top, what is top? Top 1. Stack of 1, what is stack of 1 here? It is element, that is 20. Now similarly 30, it checks whether it is full or not. It is not full. Similarly top is incremented, top points to index 2, and then it is inserted. For 40, it is not, is full, returns false. Top plus plus, and 40 is inserted into the stack. And then 50, it checks whether it is full or not. It is not full, so returns false. Top will be incremented and 50 is inserted. Now if we have another element 60, it checks whether it is full or not. We can see the stack is full, so we will get this error message, that is stack is overflow. So this is the push operation. Now let's see is full function, and then we will go for pop. Okay, let's see is full. Now it checks whether this stack is full or not. So we have only two possibilities, 0 or 1. That is it, so it returns integer. Integer is full. It doesn't take any parameters. So okay, if some condition, I will say it later, else if it is full, then we should return 1, else we will return 0. Now how? Okay, is full. See here the stack is full, right? Here top is 4. Top is 4 And what is size? Size is 5. That means whenever the top reaches size -1, the stack is full. So our condition is this one. Whenever top equals size -1. Here size is 5. 5 minus 1, 4. 4, what is top? Top is 4. 4 equals 4. So it returns true. That means 1. Else it will return 0. Okay. Now let's see pop operation. Pop. Okay, what is the operation of this pop? It will remove the topmost element from the stack. Wherever the top is pointing, that element will be removed. Okay, so it is returning something. So integer, its return type is integer and pop, and it is not taking any arguments. Now pop, we cannot directly return that element. We should check whether it is stack, whether the elements are present in the stack or not. So if is empty, if the stack is empty, then we can write return 0. Here we can write printf stack underflow. Now else, if it is not empty, then we should remove the topmost element and then decrement the pointer, that is top. The value of top will be 3. Okay, now first of all we should decrement. Okay, first of all we should return the element, return stack of top element, and then we should decrement the top, right? So here itself we can write minus minus. Okay, this is the post decrement. If we write minus minus top, first of all top will be decremented and then the stack value will be returned. Okay, if we write top minus minus, that means the top value is returned and then the top value is decremented. Okay, now we are returning the stack element, that is here we are returning 50 and then top will be decremented, that is 3. Now so if you perform pop operation again, it checks whether it is empty or not. So clearly we can see that it is not empty. So else return, we will get in the, it will return false. Now in the false statement, return stack of top minus minus, right? Stack of top. What is stack of top? 40. So 40 will be returned and top will be decremented. It's gone and value of top is now 2. Now again if we perform the pop operation, it checks whether it is empty or not. It is not empty, so again 30 is returned and pop points to 20. Again if we perform the pop, it is not empty, so it is returned 20 and then top points to index 0. Now if we perform it again, 10 is returned and now top points to, now top is -1. So if we perform pop operation again, here the stack is empty, so we will get this error message, warning, message as stack underflow, and 0 will be returned. Now we will see what is empty. Is empty. It checks whether the stack is empty or not. So we have two possible values, 0 or 1. 1 says that it is empty and 0 says that it is not empty. Now so it returns an integer value, is empty, and it doesn't take any parameters. So if top is -1, then this stack is empty. So if top equals -1, then return 1. That means stack is empty. Else return 0. It represents that stack is not empty. Okay, this is the is empty operation. Now we will see traverse operation. Okay, now it's traverse. Traverse just prints all the elements which are present in the stack. So it doesn't return anything, void traverse, and it doesn't take any input parameters. So we are declaring an variable something I. Now for I from 0, say we have some elements 10, 20, 30. Let this be top, and top points to 2. Now for I equal to 0, I less than or equal to top, because we should print all the elements from 0 up to top, that is 2. I equal to 0 to I less than or equal to top. That means we have to print 0, 1 and 2, that is 10, 20 and 30. So I plus plus printf %d stack of I. That's all. This is the traverse function, and now it's time for peek operation. Peek operation just returns the element which is present in the top, but it doesn't remove it. Okay, pop operation removes the element, whereas peek operation just returns it, just prints it. Okay, just returns it, but it doesn't remove that element from the stack. Okay, now I am saying that it is returning, so it integer peek, it doesn't take any argument. And now peek, it just checks whether if is empty. It checks whether if the stack is empty. If the stack is empty, then return 0, or else we can write a printf statement saying that stack underflow or no elements in the stack, your wish. Else we are returning return stack of what's that, top, but we don't decrement the top value here. That's all. This is the peek statement. Thank you guys. This is all about the implementation of stack. Thank you.